With all the hype around solar power and electric cars lately, you've likely at some point had the thought, why don't we just put solar panels on a car and charge them indefinitely? Well, last year I explored this idea and made this car that charges using only the 3 solar panels on it. And while this added a bit of range, it was far from infinite. So in this video I'm exploring this concept a little further and making some modifications to my solar powered car to finally hunt down that infinite range. So last September I did an entire video on building this solar-powered electric go-kart thing. It actually turned out really cool, and on a good sunny day it has a range of around 100 kilometers. And on just the batteries alone that range is closer to 60 or 70. And while that's cool, right from the start of this project, my whole idea was to explore the possibility of something producing more energy than it uses, and essentially having an infinite range, theoretically, on a perfect sunny summer day. It has 3,000 watts of power, 4,000 watt-hours of battery capacity, and generates about 450 watts of solar power when driving in the clear sun. So to dramatically upgrade my range, I'm going to have to add quite a few more solar panels to generate enough energy to sustain what it uses. So first I just took it out on the road and just did a little test with it just to get an idea of how many watts it's burning on average. And from this test it looks like it's burning anywhere from about 200 to 800 watts per motor, assuming it's not climbing a steep hill. So I think I could realistically give this a burn rate of say 600 watts per motor or 1200 watts. If I can get a solar grid to produce more than 1200 watts, I should be able to sustain this indefinitely while it's sunny. So rather than modify the structure of the car, I'm going to be building a trailer that the car will tow that'll host a solar grid. So for the main frame of this trailer, I'm using some 1x2 inch steel tubing with a thickness of 0.065 inch. And first I'm just measuring out my 4 main pieces and then cutting them each with a 45-degree angle. And once I had a piece cut, I'd use a sanding disc in my angle grinder and just clean up that edge to get them ready for welding. So basically, I'm just making up the main rectangle of the frame right now, and it's 14 feet long and 42 inches wide. And this should give me enough room for 6 175 watt solar panels. And to weld these pieces together, I'm using this cheap flux core welder that I've had for a decade, and fusing this tubing together around all 4 sides. And I'm definitely not the world's greatest welder, but I can weld somewhat structurally, so I'll just clean this up with an angle grinder. That's what they're for anyway. And now that is a perfect weld. So next I added in 1 cross member with some extra steel I had around. And now I'm going to add on the tongue using this 2 inch by 2 inch steel tubing with that same 0.065 thickness. Once I had that welded in place, I'm using some more of the 1x2 to brace the tongue onto a couple other points on the frame. With the main portion of the frame rigged together, it's now time to add some wheels. Now the cheapest and definitely most wasteful way for me to get these wheels is to just order another bike like I built the original car out of. That gets me two 20-inch fat tire wheels, identical to the ones that are on the car, for about $300. And if I wanted to buy an individual wheel, it costs about $300 per wheel. So how does that make any sense? Anyway, I'll just throw out the rest, I guess. So with these wheels, I roughly measured out about how wide of a dropout I would need. And then I did some quick maths before I cut up some more steel. So what I've basically done here is weld together a rectangle with a pocket at each end to house my wheels. And then I'll weld on some of the steel plating that's going to accept the axles of the bike wheels. So first, to make these plates, I'm using some 1/4 inch thick plate steel. This piece is 3 inches wide, and I'm just cutting some 3.5 inch long sections of this using my chop saw. Then I'm marking out an axle-sized hole for the bike wheel and drilling that through with a pilot bit. And then my 3/8 inch final hole size. With all 4 of my pieces cut and drilled, I'm using a cut-off wheel in my angle grinder to cut out the width of this hole so that the bike axle can drop out the bottom. So now back to assembly. With my first plate, I just measure out the center and then weld this square right here. And then I'd mark out the center on the opposite side and use a clamp to hold this snug. While I put the wheel in place and measure from the edge of the frame to the edge of the rim to see if my wheel is running square to the frame. I'd make some little adjustments with the clamp until I had the same measurement at the front and back of the wheel, which meant my rim is more or less square to my frame and these plates can be fully welded on. This really isn't a precision build, it's more of a proof of concept and prototype. So this doesn't have to be absolutely 100% perfect, but I am trying to do the best I can with the tools I have available, which really isn't many for this type of job. I must say my welding is getting better though, that looks like it might not fall apart. So with my axle framing completed, I can take this over to my main frame and weld this on. And then take this completed trailer frame outside for some sanding and paint. I used a bunch of sanding discs in my angle grinder to get rid of this rust on the steel because it's been sitting in my shop since last year, and it's done a bit of oxidizing. Oxidization? Rusting. Then I'm just using some regular trim-clad rust paint and painting this aluminum silver. Now I can bolt on my bike wheels and move this trailer frame inside and start working on the solar components. For my solar panels, I'm going to be using those same flexible solar panels that I used in the first video. And the reason for that is weight. These flexible panels only weigh about 7 pounds, and a rigid manufactured panel weighs about 60 pounds, and I'm not really sure why. So in order to save a bunch of weight, I'm going to keep using these flexible panels and make up some more wooden frames to be the rigid portion of the panel assembly. For that, I'm just using some of these cedar fence boards and ripping them down to width, and then cut in some 45-degree angles to make a rectangle that's about a ½ inch wider and longer than the panel itself. So now the wood portion of this panel will weigh about 4 pounds along with the 7 pounds of the panel, giving the assembly a weight of 11 pounds versus 60 of the pre-manufactured aluminum frame panels. And for a vehicle, every single pound you can save makes it more energy efficient, and this is literally going to save me hundreds of pounds. To match the car, I took these wood frames outside and gave them a coat of some vibrant red spray paint. And now we're ready to start assembling my solar trailer. So I'm going to be bolting each one of these frames directly onto the trailer. So to do that, I first clamped the frame into its final position, and then I drilled through the frame and the steel with a bolt-sized drill bit. Then I took one of these gripping nut things and hammered that into place into the wood. And then I can bolt this in from the bottom side, and that way when the solar panel gets glued down on top of this assembly can still be removed from the frame just by simply undoing that bolt at the bottom. Now I can start fastening the flexible panels to these wooden frames to create the rigid panel unit. So first I just laid out a liberal bead of some caulking I had just laying around the shop. And then I stuck the solar panel on top of this and used some stainless steel washer and screws as a second method to fasten this to the frame. Now I'm going to install a hitch, and for that I'm just using a normal trailer ball hitch. This coupler slides perfectly over my 2-inch channel, and I can bolt that into place. And now I have to install a ball on the back of my car. So I have some of that leftover 1/4-inch steel plating that I'm going to rig up to hang a few inches off the end of the car with a ball on it. Now instead of welding this on, where I'd have to remove all the electronics and the floorboards, I'm going to bolt this into place so that I don't really have to remove anything. Now that I have that dry fit and I know it's going to work out, I can remove that and take it outside for some paint, and then do the final installation. So now I need to wire these new panels into my car battery. I have 9 panels, all of the same spec, and 3 of them are already connected in series on the car. So I'm going to do that same series connection in groups of 3 with the remaining 6 panels on the trailer, so that I'll have 3 groups of 3 panels each that'll then connect into the charge controller in parallel. So to do a series connection, I can just take the positive and negative wire of 2 panels and connect them together. But in order to get rid of some excess wire, I'm just going to cut these off and install some new MC4 connections. It's the exact same thing, just shorter wires. So now I have my 2 series connections between the panels and my remaining positive and negative lead ready to go out to the charge controller. Now I can do the same on the remaining 3 panels at the back. So a quick explanation of what's going on. Each of these panels is 18 volts, 175 watts, and 9 amps. So when I connect a series group of 3 panels, it's basically giving me one big panel with an operating voltage of 54 volts, 525 watts, and 9 amps. Then when I bring these 3 panel assemblies into the charge controller in parallel, the charge controller is receiving 54 volts, 1575 watts, and 27 amps maximum. Now I can start running the remaining wires along the frame of the trailer up to the charge controller. So to connect my 3 panel assemblies into the charge controller, I'm just going to use one of these branch connectors that basically connects 3 positive or 3 negative wires into one wire that goes directly into the charge controller. To make it easy to attach and detach, all the wires will hook into these with some MC4 connections. So it's easy as this to hook up my trailer. One more thing, on all the positive leads I just put some of these inline 20 amp fuses just to protect each run of individual panels. And that's the wiring complete. This should now charge the batteries with a maximum input of 1575 watts. So now I want to do just a couple quick touch-ups to my car design before I take this out on the road. First of all, right now I'm just using the normal cable brakes that came on the bicycles that are pretty squeaky and don't have much stopping power. So I'm going to upgrade these to some hydraulic brake lines. And now my brakes have quite a bit more stopping power and makes me a little more comfortable in this rickety machine. I also added on a rear view mirror. And a battery voltage monitor so I can get a rough idea of how much capacity I have left. Now it's time to see how far this thing will drive. So I started this trip at shortly after 10 with 117 kilometers on the odometer, thinking that if I can put on 300 kilometers in one day, that's gotta be considered infinite range for a thing that goes 35 kilometers an hour and has a 60 kilometer unassisted range on these very same roads. I had a perfect clear blue sky day for filming this, and by noon we were producing about 1,350 watts of consistent solar power. I filmed almost all of this just clicking off laps around some side roads near my house, and by 2 o'clock the battery was still almost completely full. However, I have only gone just over 80 kilometers because of all the stopping and starting involved with filming. So I called in a stunt double so that I could still get these shots, but we could keep the car on the road driving with almost no unnecessary stopping. By 4 o'clock we were up to 130 kilometers with still a nearly full battery at 53.5 volts. And an hour later we had added on another 30 kilometers. But thanks to some clouds rolling in and the lowering sun, we're just now starting to monumentally eat into the battery capacity, showing 52.5 volts, which is more like 75% or so. Since our solar input dropped from about 1,000 watts an hour ago to about 350 watts in the clouds right now, for the first time during the day we're no longer producing an equal or even a greater amount of energy than we're using. Luckily, by about 6 o'clock the sun did come back out and we were able to generate about 500 or 600 watts again, but that's going to be short-lived because that sun is setting fast. By 8 o'clock we were all the way up to 240 kilometers, but our solar input was down to just 55 watts, and our battery was getting critically low at 48 volts. And sure enough, about 10 kilometers later, just as we were running out of sunlight, as if this was written in a poem, our solar-powered vehicle rolled to a stop. I just want to show you quick what happens when this runs out of energy. It'll go for a little bit and then run out of power. And then as the solar panels collect more energy, you'll get little bursts of throttle. As the battery regenerates, and obviously that'd happen a lot quicker if there is more sun. So the total range of this was 250 kilometers. But had I used the perfect time of day better around 10 a.m. to 2 p.m. when I was doing a lot of filming, I'm 100% certain we could have got this to 300 kilometers. And I'm like 50% certain you could do like 400 kilometers on this if you perfectly used your time. Which is absolutely insane for a thing that has a range of 60 or 70 kilometers with just the batteries. And definitely, theoretically, infinite range. Obviously this has no real-world practical purpose, at least not yet, but that doesn't mean there wasn't a lot of value in what was learned here, and that knowledge can be applied to future projects. And I hope some people watching this video can use this as inspiration to try something that nobody thinks will work. As always, thanks for watching my video, and if you can, hit the like button, as that greatly helps the algorithm boost these videos and fund future projects. I'd also love to know what you think of this rig in the comments below, or any ideas to make it better. And until next time, thanks for watching.